Alright, so in this example, we're going to go ahead and work out another indefinite integral. Um, Looking here at what we have cosine over 1 minus cosine squared of x. We need to find the function whose derivative is given by this here. Uh, One thing you might want to do is try and simplify this as much as you can before you try and take the antiderivative, or before you try and find, I should say, the antiderivative. So one thing that I notice here is that we have 1 minus cosine of x. Now if you remember back from pre-cal in your trig identities, we have, or you should remember, that sine squared of x plus cosine squared of x is equal to 1. And if I solve for sine squared of x, I have sine squared of x is equal to 1 minus cosine squared. And that's exactly what we have in our denominator. So what I can actually do is I can rewrite this integral as cosine of x over, and instead of 1 minus cosine of x, I can actually just write sine squared of x. And then we have this dx here. And you might be thinking, well, what does that do? Well, what I can now do is expand this sine squared of x, and I can rewrite that like this. I can say cosine of x over, and instead of sine squared, what I can actually do now is rewrite this as sine of x times sine of x. And keep in mind, sine of x times sine of x gives us back this sine squared. So I'm not really changing the problem, I'm just rewriting it. But now what I notice is that I now have this cosine over sine of x, and I forgot I should always keep this dx coming along for the ride. But anyway, going back to here, I now have cosine over sine x. Well, cosine over sine, keep in mind that's just cotangent, so that, let me change the color here, this thing in red will turn into cotangent of x. And then, well, what's left? Well, think about cosine as cosine times 1. And so what I have here, let me do this in purple, I have 1 over sine of x. Well, what is the derivative of, oh, I'm sorry, what is 1 over sine of x? 1 over sine of x, if you remember back from your pre-cal identities, is going to be secant of x, right? 1 over sine is secant, and 1 over, oh, I'm sorry, no, that, my bad, that this identity should not be there. Let me go ahead and erase that. Give me 1 second. So sorry, I don't know what I was thinking. I think I was thinking 1 over cosine, but that I'm looking at 1 over sine here. That's actually cosecant. So let me get out my pen here. Cosecant of x. And this is cosecant of x, and then we have this dx right there. Okay, so what that means now is that we need to find now a function whose derivative is cotangent of x times cosecant of x. Now, you should know what this is. Hopefully by now you should recognize this, but if you don't, let's think back a little bit. So remember, if I take the derivative, d dx of cosecant of x, I get back negative cosecant of x times cotangent of x. Now, this looks very, very similar to what we have, almost identical, except for this minus sign here. Well, I can think about dividing both sides by -1, and if I think about taking the negative to the outside of the ddx here, then this becomes, so if I multiplied both sides by -1, I now have that this is cosecant of x times cotangent of x, which is exactly what we have here inside our integrand. Now looking at this, I'm looking for a function whose derivative is given by, cotangent of x, cosecant of x. Well, here's the function whose derivative is given by this right here, which is exactly what we need. So this ends up just being equal to negative cosecant of x, and then we have to tag on this plus c, our constant. Now, if you think about taking the derivative of negative cosecant, so if we work backwards just to check our work here, and I'll do this in blue here, the derivative, that's not a very attractive color. Let me find something a little bit brighter. So the derivative d dx of negative cosecant of x is really just the same thing. It's going to be negative, and then the derivative of cosecant of x, we saw the derivative of cosecant of x is going to be, oops, I boxed in the wrong thing there, is going to be negative cosecant cotangent. So we'll have negative cosecant cotangent. And then again, we see that the two negatives make a positive cosecant of x cotangent, which is exactly what we need here. So you can always just check your work and see if this does in fact give you back what you had inside your integral. So that's it for this problem. We're done with this one. I can put it in a pretty little box and say that this is my final answer. This is an antiderivative of what we were trying to originally do, but keep in mind that in order to start this problem off, we had to go ahead and rewrite the problem and kind of use some identities to help us simplify it to something that we know.